This video is for those of you that are doing the paired t-test. So what I've done is I have put a document together that will walk you through how to use Minitab to do the math portion of your report. Not only does it give you step-by-step instructions for how to use Minitab, it also gives you, after each section of steps, it gives you a double-starred paragraph that kind of explains to you what you need to be including in your report, what you need to be talking about from what you run in the report, what you need to be presenting. Now this is geared towards Minitab. At the end of the video, I will show you how to run the test in the calculator. However, Minitab will do everything for you, and it will transfer anything that you do into a Word document for your report. If you're working in Google Docs, you could always transfer it into a Word document and then copy and paste it into your Google Doc, but Minitab will do everything for you. If you use the calculator, you will still get the same information, you will still do the same summaries, you will still report out on the same things. It's just not going to transfer into your document for you, so you'll have to create those things on your own, but I will show you that at the end of the video. So for a paired t-test, I've given you an example right here. First, you'd want to start with an introduction, and this introduction should just talk about why did you choose this question, why were you interested in it to begin with. And in order to investigate whatever it is you're interested in, you need to collect a sample. So that sample either needs to be a random chosen sample if you're asking some type of question to people, or if you're implementing a treatment, those treatments need to be randomly assigned. And this paragraph needs to just talk about how you assured that that sample was random, and also explain why your sample represents a paired data. So a paired data test is different from a two-sample t-test because your two different samples that you take are paired together in some way. For example, my question of interest is my tutoring making a difference for my students? So I go in and I have 5 students in my class. Naturally, your sample size needs to be much bigger than this. Typically, you need at least 30 in your sample size, but I'm going to keep it short for the video. And for these 5 students that I have in my class, I'm going to give them a pre-test before I start the tutoring process and see what their score is. And then I'm going to give them a post-test to see what their score is after I finish my tutoring session. So unlike a two-sample T, where you usually have one group's average compared to another group's average to see if there's a difference between those two averages, these two groups are not unrelated. This pre-test and this post-test are paired to Megan. She took both of them. So I couldn't mix this data around and put the 63 down here because Spencer didn't take that test. So if they are paired somehow to this one object, then we're really not interested in this group versus this group. We want to look at the difference between these two scores to see if there is a difference. And we typically work with post minus pre. Alright, so the first thing I'm going to do is I'm going to summarize this data that I have collected to see what it's telling me. So I'm going to enter this data into the spreadsheet, and I'm going to type it in exactly like you see it here. So I'm going to use this gray box under C1 just to label this as student. C2 I will label as pre-test, C3 as post-test, and C4 as the difference between those two test scores. I have student number 1, Megan, Stephen, Tyson, Taylor, and Spencer. Okay. And I'm going to enter their pre-test scores under pre-test. And I'm going to enter their post-test scores under post-test. Okay, Now, difference, you could subtract these yourself if you wanted to, but Minitab will do this column for you, so you don't have to do the math for every single problem. So if you click in the first empty cell right here under difference, which I spelled wrong, but y'all get it. And then once you've highlighted that first box where you want that first difference, you're going to click the f of x, the function tab up here at the top. And then inside this expression box, you are going to highlight the post test, because when we do this subtraction, we want it to model what happened. So with Megan, she went from a 47 to a 63, which means his score, hang on, I gotta pause this for just a second. Okay, sorry about that. And okay, had to remember where I was. So when we're looking at this difference, we want that difference to show whether they improved or not. So because Megan went from 47 to 63, her score went up. We want that difference to be positive. So we definitely want to do post-test minus pre-test so that that difference will be positive. So I'm going to highlight post-test, post-test, highlight post-test, hit select underneath it, and then hit the minus key because we're going to subtract what we made on the pretest, and then highlight the pretest and hit select, and then you can hit OK. And when you do that, it's going to automatically compute the differences for you. And when you have a sample size of 30, that's really going to save you a lot of time right there. So it looks like everybody really improved except for Spencer, who went down 1 point. So to graph this, we are going to, where is this? All right, that's what I just explained to you. So for number 2, we're going to choose stats at the top of the page, and then choose graphical summary. Well, I should have had a base. Oh, I do. Oh my goodness. Okay, so number 2, choose stats, then choose basic stats, and then choose graphical summary. And then you're going to click in the variables box right here. You're going to highlight the difference variable because that's really the only thing we're interested in. You're going to select the select button underneath, and then you're going to hit OK. All right, so what this is going to give you is just a summary of the differences. It gives you a bar chart, also gives you a box and whisker graph. It gives you some confidence intervals. We didn't do confidence intervals for medians, so I'm going to right click on that and delete it. It's an early morning for me, guys. I'm so sorry. Just clicking on the wrong things. Anything here that I am not familiar with, I'm going to delete. Like, we didn't talk about Anderson-Darling, but notice that when I right clicked that, it highlighted this whole box, and I definitely don't want to delete everything. So I'm going to make sure that just Anderson-Darling is highlighted, right click, and delete that. And you can delete the A squared, the entire row. We're not talking about testing yet, so we can even take that p-value out for right now. We did talk about mean, standard deviation, variance, but anything that if you were presenting kurtosis, I don't know, that would be a potential question for somebody if they ask you and you don't know what you're talking about, you definitely want to delete that. So 95% confidence interval for median. I didn't really do medians. Make sure you also delete the numbers associated with whatever you take out. Okay. Now, once you've deleted everything that you want to delete, and you think you have a good little collection of graphs that you can use to explain things, if you right click in the gray area, you'll notice that there's an option to send your graph to Microsoft Word. You can even send it to a PowerPoint if you were adding it to your presentation. So if you send this to Word, it will, well, and I was in my table when I did it, but you can put your cursor anywhere you want, and it's going to pull it to wherever you want it in your report. That way you don't have to recreate your graphs and redo everything yourself. Minitab's already done it for you. So notice at the bottom of that section, you'll see a double starred paragraph that's going to explain to you what you need to get from this. So in your Word document, summarize what you see. For the differences, use the CUS acronym, which we talked about at the Martinsville site. I don't know if the Danville site uses that or not, but it just stands for C, which is the center. So you want to talk about the mean difference is 8.8. So it looks like on average, they're all going up about 9 points. U is anything unusual. We didn't really see anything unusual in this data set. S is your spread, which is your standard deviation. So this has a standard deviation of 8.98. And your last S is your shape. Is this graph symmetric? Is it uniform? Maybe the same all the way across? Is it skewed? Right skewed or left skewed? You need to talk about what you see in that graph. So if you average the differences, if we're really not, was it exactly zero? Zero meaning there was no difference in the test score. So if it's not zero, in this case it's not, it's 8.8, our average was above zero, then I think that my tutoring is making a difference. The test scores are going up by about 9 points. All right, so that's what I'm going to try to prove. I'm going to try to prove that my tutoring is helping and that these test scores are above zero, or these differences in test scores are above zero. And you want to talk about that when you summarize your data. Now, what I can't say is, oh, it was 8.8, so I'm making a difference. I actually have to run a test to try to show that I have evidence of that. And because this may just be sampling variability. If I did this tutoring session with another group, then I may have a negative for them. They may go down in test scores. So I have to see if this difference is big enough to say that my tutoring is having a positive effect on these kids. So before I run this test, I do need to check the conditions for this test. Number one, it has to be a random sample, which should have already been made clear in your introduction and how you chose who you were working with. It has to be a normal distribution, and if you've used a sample size that's greater than or equal to 30, then this condition is taken care of. You can end that condition check right here, and that is something that you should have done in your sample, so you shouldn't need this last part. If your sample size is not at least 30, then you would need to make sure that your distribution could be considered normal. One way to check that is in your calculator. If you put your data into stat edit in your calculator and then go to second stat plot, go to the last graph and hit zoom 9. If that graph appears to be linear, then you can assume this is normal, but you shouldn't need that part. Your sample size should be greater than or equal to 30. Your 10% independence, whatever your sample size is, in your case it should be 30. In my case it was just 5. But if I did 5 times 10, I would have 50. That has to be less than what your population is. And for me, the population would be every student that I have in my class. Mine may not work out. I may not have 50 students in my class alone that I would be tutoring. So if your conditions are met, then in your Word document you can make a statement that all your conditions have been met, so we're going to continue with the test and the interval. If your conditions are not met, you're going to need to adjust your sample size until they are, so that this test will be a valid test. Now, once your conditions have been met and you've checked all of those, we can run the test. And Minitab will do that for you. Now that I've copied this graph over, I'm going to delete it. So we're going to go to Stat here at the top. We're going to choose Basic Statistics, and we're going to run a paired T. From the pull-down tab, step number 4, we're going to make sure that each sample is in a column. We are going to click in sample 1, and we're going to highlight the post-test variable and hit select. Then we're going to click in sample 2 and hit the pre-test variable and hit select. You'll then choose the options button, and this is where we're going to enter our test information. So enter your confidence level. Usually we use about a 95% confidence level. We need to enter our hypothesized difference, which is always going to be, we're going to assume when we start this test that there is no difference in test scores. That will always be 0 for a paired t-test. And then we're going to choose what, for the alternative, what it is that we're trying to prove. So what I was trying to prove is that the difference between the post and the pre is actually greater than 0 because I feel like I'm having a positive effect on my tutoring. The scores are going up for the most part. All right, so once you've got that entered, you can click OK in this box and OK in that box, and it's going to give you this t-test report that gives you a lot of information. You can right-click right here beside paired t-test and confidence interval, and you can send that to Word as well, and it will put that entire report into your document. Now, what you'll notice is this particular one did not give me a confidence interval, and we'll talk about that in a minute. It does tell me for the test exactly how my null hypothesis is laid out, exactly how my alternative hypothesis should be laid out. It gives me the t-value for the test, and it gives me the p-value for the test, which is going to be what we link our conclusion on. So if you scroll down to below the confidence intervals, that first double-starred paragraph, in your Word document or in your report, you want to write your conclusion from the test linked to that p-value. If your p-value is less than 0.05, you're going to reject the null hypothesis, which means you do have evidence of the alternative. If your p-value is greater than 0.05, you're going to fail to reject the null hypothesis. You do not have evidence of the alternative. Now, this 0.05 is the alpha level that we set for the test. The reason this is 0.05 is because we did this test at a 95% confidence level. That p-value would change depending on what you're doing your confidence level on, and we'll talk about that in another video. We'll get to the confidence interval in a minute. I'm going to go ahead and make this conclusion based on my p-value. So for this particular result, I got a p-value of 0.047. So because my p-value is equal to 0.047, and oh goodness gracious, I can't type. And that value is less than the 0.05 alpha level that I'm testing at, then I can reject the null hypothesis, which means I have evidence of the alternative. Now, I need to talk about this in context of my problem. So the alternative that I was trying to prove is that the difference in the mean test scores were greater than 0. They were positive. So I have evidence that the mean difference of the test scores is greater than 0, which means my tutoring is having a positive effect. Okay. Now, we can use a confidence interval to support this claim. The only problem is the confidence interval is not computed on a greater than, for Minitab, it won't compute on a greater than alternative. We can only do it for a not equal to. And sometimes when the p-value is really close to that alpha level, it doesn't match up, but we'll see what happens. So for the confidence interval, we're going to repeat all the steps of this test right here. The only difference is the alternative should be not equal to. So I'm going to go back to stat, back to basic stats, run a paired t. All of my information should already be in there. I just need to choose options and change that alternative to a not equals. When I hit OK, OK, it runs another test. It does change my p-value to 0.09, which is going to be tricky for this because my confidence interval is really not going to support what I did right here because that p-value is going to be different, okay? So in that case, you may want to change your whole test to not equals and use this p-value. In that case, if the p-value was 0.094 compared to that, this would be greater than 0.05, which completely changes that result. In that case, I'd have to fail to reject the null hypothesis, which means I do not have evidence that the mean difference of the test scores is different than 0. Okay, which means my tutoring is not having a positive effect. And with this confidence interval, since we've already run the report, I'm just going to copy just that confidence interval and paste it just below here. And so here's how it supports it. What our null hypothesis was is that the difference in these test scores was 0. There was no difference in them at all. And because 0 is in the confidence interval, then I can say we are 95% confident, since that's the confident level that we ran this test on, that the interval from negative 2.35 to 19.95 captures the true mean difference in test scores. And since 0 is in the interval, we don't see a difference. And that supports our conclusion we made up here that we don't have evidence that it's different. So you just you have to play around with the test and the confidence interval and make sure that you're doing it in a way where they support each other. If you have questions about that, please feel free to ask me. Or if you're in Danville, you can ask your math teachers down there. But there's a final paragraph that you do need to write. We're going to talk about that in another video. Let me show you how to do this in the calculator real quick. So with the calculator, you'll have to do your own graphs. I mean, your calculator does graphs, but you would have to draw your own graph anyway because you're not going to be able to transfer it from the calculator. But you can do the testing in the calculator to get this p-value you need for the conclusion, as well as this confidence interval. If you go to Stat and choose number 1, Edit, and you go up, if you have information in there already, you can go up to L2 and hit Clear, go up to L1 and hit Clear. We're just going to type in all of the pretest results into L1. So let me type those in really quick. And then we're going to type in all of the post-test results into L2. Your calculator will also compute the difference column for you. You do not have to subtract them all on your own. If you go up to L3, down here beside L3, you can type in what subtraction problem you want to be represented in this column. So I can take the post-test score, which is L2. L2 is in blue above the 2 down here at the bottom. So if we do second 2, that will bring an L2 right here, and then hit the minus key. Second 1 will subtract the pretest, that's an L1, and when you hit enter, you'll already have all of those differences in L3. Since we're only interested in this difference column, you need to remember that those differences are in L3. When we go to run the test, we'll go to Stat, right arrow over twice to Test, and you will just be using the basic t-test for a paired t-test. So I'll choose number 2. It asks me if I'm working with data or if those stats have already been computed. We have the list of data. We want to put in the null hypothesis, which we are assuming from the beginning there is no difference in those two tests, which is 0. Our list is in L3, so we're going to hit second 3 to change that. Frequency is always 1. And we wanted to do a greater than alternative hypothesis. So we're going to calculate that. And we get that p-value of, well, this one gives me a p-value of 0.07. So that one would have been a greater than. The calculator will compute a little differently than Minitab. To be honest, I'm really not sure why that happens, but that would have supported the confidence interval here. So you can also do the confidence interval if you go to stat and then back over to test. You would go down to number 8, which is just your basic t interval. We're again using data that's listed in L3, frequency always 1. Just need to make sure that your confidence level supports the 95% confidence level we're doing with this test, and then calculate. So you can transfer those over to your test as well. Now, make sure before you wrap up your report that you are writing a final paragraph that explains what type of errors you have made in your study and what happened if you change the alpha level. So look for that. It is called errors and alpha level.